Exercise 11G looks at the integration of circular functions. So the first thing we're going to do is we're going to think about differentiating. So to differentiate sine, we multiply by the derivative of what's inside, so the 2, and change the sine function to a cosine function. And then inside the bracket we remain the same. So we get out 6 cos 2x minus 5 in this particular case. Using this, we can undo it. So we have the function 6 cos 2x minus 5, and we want to integrate it. So our first step is to do the opposite of what we did before. So instead of having cos, we're going to have sine. So the bracket again doesn't change, but now we just have to divide by that derivative. So the derivative inside, the 2 from inside, is what we have to divide by, because previously that is what we multiplied by. Cos was changed to the sine because previously sine was changed to cos. Then we just need to simplify that to get 3 sine 2x minus 5. Now looking to differentiate cos x squared in order to be able to do the opposite in a moment. So thinking about this, the first step is to do the derivative of what's inside, so that would be 2x. Then multiply it by negative sine of x squared. Negative sine because when you differentiate cos, cos goes to negative sine. Simplifying this, just writing it differently, and then that's done. Now we've got to undo it. So previously we switched the cosine to negative sine. So now when we integrate sine, we now need to switch it to negative cos. So the very opposite of what we've just done. So 2x times negative cos x squared. And then we do have to still divide by that 2x, so the derivative of the bracket. Then we simplify that and we get out cos x squared. Alright, so these are our in general formulas. This shows us the going from the differentiation to the integration, so what's actually happening. Pretty much when you go from a cosine, when you go from a cosine and you're integrating, you turn that into a sine, positive sine, and you divide by the derivative of what's inside. When you go from a sine function, you go to a negative cosine function, and you divide by what's inside. In general, this looks like these two formulas. So we've got the integral of sine kx plus a is equal to negative 1 on k, cos kx plus a, and then it's just a general formula, so plus c. Same deal for cosine, integrating cosine, except we're going to go to a positive 1 on k, and then change it to sine.